In today's lesson, we're going to be using the distributive property in order to create equivalent expressions. What we're really trying to do is we are trying to use the distributive property in order to simplify a complicated expression or a complicated equation. And I'm going to show you how we're going to do this. And really, it's all about using your math sense. So being able to look at, say, 10 times 12. Well, I could break 10 times 12 into 10 times 10 and plus 10 times 2. So it's really about using your math sense and being able to apply that distributive property. When you apply the distributive property, we are looking at it metacognitively, meaning that you're thinking about your thinking and just writing down that in your thoughts. So let's go ahead and show what exactly it is that I am talking about and how using math sense is a lot like using your distributive property. Okay, we're breaking down things into parts that would make it easier for us to solve, but we're just kind of writing that out. So let's take a look at the distributive property of addition from our last lesson, because we're actually going to apply this to that 10 times 12 concept. And right now, you might be thinking, game over, man. I have no idea how this is going to relate. But just give it a second. Let's talk about it. So if we take a look at this, remember, here's the distributive property of addition. So we are distributing this 10 to two different numbers, and then that is the sum of those two numbers or those two expressions added together. So we're doing 10 times 12. I wanted to show you guys, and I've talked about this in other videos, there's different ways to show multiplication, different ways that it can be written. Don't blame me, blame the math gods. So 10 times 12 can be written like this with an asterisk. It can be written like this with parentheses. It can be written like this with a dot in between them. And then what you typically are normally or used to seeing is just that multiplication symbol or like a small x. So either way, these are all ways to write 10 multiplied by 12, or 10 times 12. If we were going to use the distributive property to make this a little bit simpler, we would think about math sense. Our math sense might tell us, or you might have learned in the past, is that we want to do 10 times 2, because we want to make this into something that we can know. And we know 10 times 10, or we usually know our tens facts. So 10 times 10, okay, we should know that to be 100. And then we could add 10 times 2 to that. So this is actually 10 times 10 plus 2. And this is using our math sense. This is something that we could break our problem down into. And look at this. This looks exactly like what we talked about with our distributive property of addition. We have now written the first part of our equation. This is equal to, and then we would just go ahead and fill this in, a times b. Well, a times b would be 10 times 10. Plus a times c. Okay, well, a in this case is 10, c in this case is 2. So it'd be 10 times 2. So we can break down a multiplication problem like this, and this is something that you might be able to piece together in your head if you know your math facts really well. And then we would just have 10 times 10, which is 100, plus 10 times 2, which is 20, and we could figure out, okay, this is 120. You could solve this side of the expression or the equation as well. So we would solve this expression. 10 times, well, what is this? 10 plus 2 is 12. So we would have 10 times 12. That is equal to 120. So this is still the same thing, just a different way of writing it. And you might be thinking, okay, this is a pretty simplistic problem, but what would happen if we were doing like, let's say 5 times 99. All right, so here's our second problem that we're going to work through. So the way that we could use the distributive property to simplify something like this, and this is a reason that you would use the distributive property, is we would break it down into parts that we would know already. So we can break this down into 5 times 90 plus 9. And this is really just going back to breaking it down to things that we know. We can know what 5 times 9 is. We know that's 45. And if we don't know that, let's get those math cards out and let's memorize those things. It's not bad to memorize a few things in your life. So 5 times 9 is 45. And if we add a 0 to that, because this is actually times 90, we would have 450 plus 5 times 9, which would be 45. So this would be 495. And that's just me working with my math sense and my reasoning and knowing some facts and pulling a few numbers out of my head mentally. Okay. And I'm not expecting you to do that right away, but that's where we want to get to with our ability to manipulate and work with numbers. So if we were to work this out, let's go back to our distributive property. So A times B, A times B, which would be in this case, our A is 5. Our B in this case is 90. And our C is 9. All right, and I'm just doing this to represent what we're going to show or how we're going to rewrite this using the distributive property. So A times B, which is 5 times 90. I'm going to use the parentheses to show multiplication this time. 5 times 90 plus A times C, 5 times 9. And we could solve this. We're going to do both sides at once, so let's do this. And we're in parentheses over here, PEMDAS, remember? So this is actually 99 times 5. And we don't know that, remember? That's why we broke it apart into pieces so that we could solve it easier. Eventually, I mean, we can use a calculator to solve this, and we could also count down. There's another strategy we could use. But if we broke it down into this, so 5 times 90 would be 450, 45, and add a 0, plus 5 times 9, which is 45. We would add those together. We would get 495. Same thing over here, 495. So this is using the distributive property to take a problem that we might not know off the top of our head in order to break that down into parts or pieces that we do know. And when I said there was one other strategy, just to cover that really quickly, we could do 5 times 100. And then we just need to subtract 5, or 1 times 5. And then we would get 500 minus 5, which guess what, is equal to 495. Same answer. Now, I'm not going to ask you, oh, did you use the distributive property to solve this problem? I would much more likely be apt to ask you, hey, can you use your math sense to help you solve this problem? And if you were able to do that, I would say, yes, this is awesome. That's what we're trying to do, is build that understanding of how you can manipulate problems to make them easier for yourself. And that's really the important thing to be thinking about when we're talking through this lesson. So if you can do that, if you can have a good idea and a good math sense about you, and you can break things down into parts that you can solve, then that's really the point and the crux of the lesson that I really want you to get out of being able to use this property.